When you send a digital message, you see a simple text envelope. But the moment you hit send, that envelope explodes into a traceable infrastructure of metadata, routing instructions, and server logs. Digital forensics treats every communication as a multi-layered artifact. This complexity is an investigator's greatest asset. Malicious actors routinely rely on spoofing, phishing, and anonymizing networks to falsify their digital identities and hide their tracks. Definitively unmasking a sender requires triangulating three distinct elements of the communication. We call this the forensic triad: the linguistic signature, the routing metadata, and the server-side logs. To understand how this triad works, we are going to deconstruct the anatomy of a single digital communication. We will start at the victim screen and trace the data backward across global network infrastructure. Exposing a cybercriminal is rarely about reading what the message says. It requires systematically dissecting the hidden infrastructure that actually delivered it. We begin our deconstruction at the absolute surface layer, the visible text payload of the message. This is the domain of forensic linguistics, a field where language and law intersect. Investigators use syntax, tone, and structural phrasing to profile an author and authenticate a document. Consider a specific case involving a staged suicide. The physical scene and a note initially pointed investigators straight to a ruling of self-inflicted death. However, forensic linguists compared the structural phrasing of that note against a baseline of authentic emails known to be written by the victim. The syntax and tone completely clashed. That linguistic mismatch proved the note was written by an imposter, prompting investigators to change the official manner of death from suicide to homicide. But relying purely on the written word carries a modern complication. AI tools like ChatGPT can rapidly learn and simulate human tones, making it incredibly difficult to assign authorship through phrasing alone. Because language can now be simulated, text analysis is no longer enough on its own. To prove an origin, investigators must penetrate beneath the payload and read the technical metadata. We shift from the visible message down to the hidden routing instructions etched into the communication, the email header. When a bad actor wants to disguise their identity, they use a technique called spoofing. They deliberately alter the header information so the message appears to originate from a legitimate, trusted sender. This unformatted text is a raw email header, the primary forensic artifact to defeat spoofing. The rule for reading it is chronological, but in reverse. Receiving servers append routing data to the top, listing stops backward to the source. Investigators scan this backward chain, moving past the recipient servers to isolate the final legitimate server IP address listed right before the spoofed origin point. This exposes the true path of the message, but also reveals an unforgeable digital fingerprint. Every time a server transmits a message, it assigns a completely unique ESMTP ID to that specific transmission. If an investigator examines two separate emails from seemingly unrelated accounts and discovers identical ESMTP IDs in the headers, they have definitive proof that a single sender is operating multiple fake identities from the same machine. An email header successfully exposes the originating IP address, but an IP address only points to a piece of hardware. To find the humans sitting at the keyboard, we need network server logs. We transition from the static text of the header into the dynamic network path, tracing our originating IP address back to its physical host server. Email relies on a client-server architecture. Messages are distributed from a central server hub outward to many connected end-user client computers. The administrators of those central hubs maintain server logs, which serve as the machine-level record of all inbound and outbound traffic handled by the router. Depending on the operating system, retrieving these logs require different tactics. In Unix and Linux environments, an investigator must locate the /var/log/maillog file to track SMTP, POP3, and IMAP4 communications. By contrast, in Microsoft Exchange environments, an investigator must execute specific PowerShell scripts to extract a file known as the tracking.log. This is the Windows Event Viewer, the primary visual interface for Microsoft troubleshooting logs. When configured for detailed tracking, it captures the exact timestamp of the transmission, the sending client's IP address, and the specific account access record. But this evidence is fragile. Administrators frequently use log rotation, where critical logs are automatically overwritten after a set file size or time frame. If those logs aren't backed up, the evidence is permanently lost. Cross-referencing the header metadata with these server logs creates an unbroken technical chain of evidence. However, physically accessing the servers to get those logs introduces massive jurisdictional and legal hurdles. Investigators frequently hit a procedural wall where technical capability meets legal limitation. Possessing the software to extract data doesn't grant the right to use it. Public internet email providers and social media platforms operate on private corporate infrastructure. They are locked behind strict privacy boundaries. In the United States, these boundaries are governed by frameworks like the Electronic Communications Privacy Act and the Stored Communications Act. These acts legally mandate that investigators secure highly specific warrants or subpoenas to compel a provider to hand over their server logs. A vendor will not produce records without one. The historic Enron investigation illustrates the absolute extreme of corporate data extraction and legal discovery. Retrieving Enron's internal emails meant pulling more than 10,000 records. Investigators had to navigate a minefield of highly personal employee data, personally identifiable information, and evidence of corporate espionage all tangled together. If an investigator utilizes advanced forensics tools to rip data without probable cause covering each specific crime they find, they violate Fourth Amendment protections against unreasonable search. That renders the extracted evidence entirely inadmissible in court. A technically flawless data extraction is worthless if it violates the law. An investigator's legal strategy is just as critical to the case as their technical execution. Successfully unmasking a sender requires triangulating the full forensic triad, the linguistics of the payload, the routing metadata in the header, and the authoritative record in the server logs. Yet, the digital landscape is shifting. Both corporate and illicit communications are moving rapidly away from traditional email and toward mobile, channel-based platforms like Discord and Slack. The platforms change, but the artifacts merely shift formats. Instead of parsing email headers, investigators now target localized SQLite databases stored directly on mobile devices. Accessing these new mobile artifacts often requires bypassing the device's operating system security, getting low-level file access through logical or physical extraction, commonly known as jailbreaking. The digital paper trail is persistent, but fragile. Recovering it requires the technical literacy to capture data before it is overwritten, and the legal authority to ensure that evidence actually stands up in court.